Chapter 16, redox chemistry. Now, the major thing we need to get done here is going to be balancing redox equations. Now, we start off with a sort of a general introduction to the idea of oxidation and reduction. Don't worry too much if it's not entirely clear what's going on just yet. Sort of all comes together with a little bit of practice later on. So, first of all, what is oxidation and reduction? Well, if pH, if acids and bases is all about H plus protons, then oxidation and reduction is all about electrons. So, substances gaining electrons, substances losing electrons. And most of chemistry involves electrons being donated or gained or swapped or rearranged. So it's a very important set of concepts for chemistry. So you've got your classic corrosion of any metallic object that occurs over time, things exposed to the atmosphere. That's a classic oxidation process. But lots of common phenomena, bushfires are redox reactions, and so many biochemical reactions are redox reactions. Now, sort of a bit of historical context here. Oxidation is called oxidation because initially it was thought of to be substances gaining oxygen. So we oxidise fuels, the propane gains oxygen, the propane is oxidised. So it gains oxygen, it loses hydrogen. Both were thought to be principles behind oxidation. Reduction was where you turn metal oxides, metal ores, into the pure metal. So in this case, a really common chemical way of doing that was reacting with hydrogen gas. So the copper oxide loses oxygen and it gains hydrogen. So that was classified as reduction. That was a long time before the discovery of electrons, which is how we explain these things these days. So let's look at a couple of very simple redox reactions. So, magnesium metal reacting with chlorine gas. It'd be quite a spectacular reaction involving fairly nasty toxic chlorine gas, which I've never been going to produce in a high school lab. Okay, what happens here? Well, what's happening with magnesium here? The magnesium metal, neutral magnesium metal with all of its electrons, is turning into magnesium ions, Mg2+. So we can take that separately to give us a half equation and just be explicit about what's happening with electrons in that case. So I'm just going over a little bit of the process to get the electrons in the right place. Now we may know that magnesium is losing electrons to form magnesium ions. That's all good and proper, but you'll see later on when we've got to add in electrons to balance half equations. Think about it this way. So we add up all the charges on the left-hand side. Now that's neutral, therefore it's got a charge of 0. This is 2+, so the overall charge, it's the only thing there. The overall charge on the right-hand side is +2. Now, where we've got to add electrons to balance a half equation, we always add electrons to the side with the highest overall charge to bring it down to equal the lowest. Think of it as a number line. So clearly we need to add 2 electrons. Electrons have got a negative charge, of course, so we add 2 electrons here to bring down the 2+ down to equal 0. Like I say, that idea of working out the overall charge on both sides really pays off a little bit later on. Now we do the same with chloride. Oh no, hang on. First of all, we describe what's happening. So magnesium has lost 2 electrons. So magnesium is being oxidised because one of the eternal truths in chemistry, in redox chemistry, is oxidation is the loss of electrons. sear that into your brains. Let's go to look at chlorine. So chlorine reacts to form chloride ions. Cl2 is going to produce 2 Cl minuses. So this time overall charge is 0 going down to -2. The higher number, think of a number line again, the higher number is 0. We need to add 2 electrons to that side to bring it down to equal -2. So what's happening to the chlorine is being reduced because reduction is always the gain of electrons. So we've got an equation going back the other way, the salt forming the native elements. So we look at the copper 2 plus is forming copper metal. Total charge 2 plus down to 0, so we're going to add electrons to the left-hand side. So again, copper 2 plus ions, the copper ions are being reduced in a reduction reaction. Now, what are the copper ions, where are the copper ions getting those electrons from? Well, the copper ions are stealing the electrons from the bromide ions. Because the copper ions are removing the electrons from the bromide, the copper ions are actually oxidising the bromide, causing the bromide to be oxidised. So we describe the copper ions as the oxidising agent, because that's what they're doing to the bromide. So it itself is being reduced in a reduction reaction, but how is it acting as an agent? What is it doing? It's oxidising the bromide, so we say it is the oxidising agent. And everything can be flipped for bromide. Bromide is being oxidised to form molecular bromine. So it's being oxidised in an oxidation reaction. What's the bromide doing with those electrons? Well, the bromide is forcing those electrons onto the copper. So the bromide is forcing the copper ions to be reduced. Therefore, the bromide is the reducing agent. So oxidation refers to what's happening to the bromide itself. Reducing agent talks about what it's doing to the other stuff. And that's what that slide says. Note that quite commonly we call them oxidising agents in the VCAR course, reducing agents. Oxidant and reductant are commonly used in many other syllabuses, many textbooks. Here's one mnemonic. Oil rig. Oxidation is loss of electrons, reduction is gain of electrons. Because you've got difficulties involving electrons being negative and sort of things go a little bit backwards, you just got to remember that. Always refer back to that idea. If electrons are being lost, it's oxidation. Okay, have a go at these questions. They should work very similarly to the examples that we've been through. See how you go. If you're struggling with them, just message me and I'll send you the solutions video.